My name is Andre, and I'm putting together a series of college algebra videos for you guys. And before we can get to the actual college algebra, we need to go through a couple of prep lessons. And well, first, our first prep lesson, we're going to be talking about the real numbers. And the real numbers consist of natural numbers, whole numbers, and integers. Well, first, natural numbers or counting numbers are just numbers starting at 1 and go 1, 2, 3, and pretty much go on forever in that sequence 1, 2, 3, 4, 5, 6, all the way into infinity. So it goes on to infinity. And whole numbers are pretty much natural numbers, but instead of starting at 1, we start at 0. So whole numbers start at 0 and go 1, 2, 3, 4, 5, 6, all the way into infinity. And integers. Integers are like whole numbers where it starts at 0 and goes on to infinity, but it also goes in the opposite direction, in the negative direction. So it goes negative 1, negative 2, negative 3, and goes on to negative infinity. And this goes on to positive infinity. But also, integers can be seen as numbers on a number line. And this is a number line. And you always want to choose a convenient place for your 0. And I usually put my 0 in the center. And let's see, let's give ourselves some room. Okay, and we'll do this here. So 0, then we have our 1, 2, 3, and this is going in the negative direction, so it's negative 1, negative 2, negative 3. And once again, this is our number line. So we call this a number line. So number line. Okay, and these particular points here, negative 3, well, this negative 3 is the same as this negative 3 here. Maybe I should choose a darker color, huh? So this negative 3 here is the same as this negative 3 here. And this 0 here is the same as this 0 here. And this 2 is the same as this 2 here. And these points, these particular points are called coordinate points. So let's see if I could fit this in here. Coordinate points. Does that look okay? Coordinate points. So the points on a number line are coordinate points. Okay? So this is a coordinate point. Let's erase this. So this is a coordinate point here. This is a coordinate point here. And this is a coordinate point here. And yeah, so integers are points on a number line, and each individual point is a coordinate point. Okay, so moving on. Okay, now let's talk about rational numbers. So rational numbers. Rational numbers are also in this, I guess, in the spectrum of real numbers. So a rational number is a real number, and a rational number is a fraction. It's 1/2, 2/3, 3/7, and it continues on to infinity. But it usually takes the form of a over b. where a is any number, so this is any number, it's any number, and b is also any number, but b cannot equal 0, because if b equals 0, then this whole thing is undefined, and this needs to come down to some number. So it can't be undefined. So if you divide these two, it needs to become some number. It can't be undefined. Where a and b are called variables. So what is a variable? A variable is pretty much a letter that takes the place of a number. Let's say a equals 2, b equals 4. So what this is doing is saying that a and b are both variables and they equal some number. So a equals 2 and b equals 4. So if we throw it in this equation, a over b, that's an a, and substitute in 2 for a and 4 for b, it gives us 2/4, which equals 1/2. So yeah, so that's pretty much what a variable is. It just holds the place of a number. It's a letter holding the place of a number. And another example of what a rational number is, it's this repeating decimal thing. That it's this is an example of a rational number. It's 0.595959, and it'll just keep repeating 59 forever. So these are the two examples of a rational number. A rational number can take the form of a over b, or it could take this form of a repeating decimal. So those are the two forms of a rational number. So let's move on. Okay, next we're going to talk about irrational numbers. And irrational numbers, it's again this decimal thing. Well, one example is this decimal thing, but it doesn't repeat. It's just 0.0100100001. So it's actually like growing by an extra 0. So you could probably estimate the next sequence is going to be 00001, so 4 zeros. But if you look at it, it's not repeating. And also, irrational numbers, another example of irrational numbers is pi. So pi, everyone knows pi is 3.14, but what a lot of people don't know is pi is an irrational number, and it doesn't end at 3.14, but it goes on forever. So if we look at calculator says that pi is 3.14159265358, and it keeps going on. But what a lot of people don't know is this 3 here is actually rounded. Pi goes on forever, but the calculator can only, display so many digits. It has to round this last one to 3. So just so that you know that pi is an irrational number. And also, if you see here, we have square root 2. So let's throw that in here as well. So square root of 2 gives us 1.4, and so forth, and ends at 5 here on this calculator. But remember, calculators can only display so many numbers that it has to round it off somewhere, because calculators can't display infinite values. So it's going to actually round the last value that it can display, which is 5. But square root of 2 goes on forever, and it is an irrational number. Okay, so let's actually do a little exercise here. It says graph the real numbers -3, -0.025, then it says graph 1/3, 0, and then graph 0.595959, graph square root 2, and graph pi. So let's go ahead and graph these. Let's see what color we want to use. We want to use a color that's going to show up, so let's use this red. So, okay, we're going to graph this -3 right here, which -3, remember, -3 is an integer, so just so that you remember, it's an integer. And also this -0.025 is also an integer, and let's graph that. It's like roughly about here. And remember, these are all coordinates, so this is the -0.025 is right here. I'll draw a little arrow so that we know. Okay. And also, next we're going to graph this 1/3, and 1/3 is going to be roughly about here. It's 0.3, but well, let's look at 1/3. What does 1/3 look like? Okay, 1 divided by 3 equals 0.33333, and this actually goes on forever. So what type of number is 1/3? 1/3 is repeating, so that looks like to me as a rational number. So just so you know, so 1/3 0.13, we'll say it's like right here. So this is 1/3. Let's draw a little different arrow. Will that show up? Okay, so 1/3. Then we have 0 here. Everyone knows where 0 is, so that's an easy one. And next we have 0.595959, which is also another repeating number, so that's a rational number. And where is that going to be located? That's going to be located around about right here, roughly around 0.6. So when you're graphing, you could just depending on how your scale is. My scale is 0, 1, 2, 3, so I'm just going to do a little estimating here for the 0.595959. I'm going to just call that roughly 0.6. That's a little more than halfway. Let's see. Let's get a green in here. Hopefully you can see that. It's not the best graphing job ever. And here we have square root 2. So square root 2 is, if you recall, it's like 1.4, and it goes on forever, non-repeating. So non-repeating decimal would be an irrational number. So square root 2 is an irrational number, and it's 1.4. And let's just use this purple color. So 1.4, we'll call that like right here. Okay. And then next we have pi, which is 3.14, going on forever. And since it's non-repeating, remember it's an irrational number. So 3.14, we'll use this yellow here for pi, and we'll just say that's roughly 3.14. Oops, 3.14, and there we go. So that is this little exercise, and if you have any questions, just feel free to drop me an email, or yeah, if you have any comments, just go ahead and leave me an email, and yeah, we'll just look for more videos that are of this college algebra prep to get you ready for college algebra, and yeah, we'll continue talking about real numbers. And until next time, see you later.